All right, first issue. So let's talk about HttpContent.ReadAsStream. Do you want to walk us through it?
Yes, this is kind of a follow-up forgotten little thing from the Sync HTTP client API. As of now, if we implement the HTTP client Sync API, the send method will work synchronously, but the returned response and its content will have no way how to retrieve the underlying stream synchronously. So in the end, the user will end up using async method anyway. So this one introduces a sync method to get to the content stream. And we plan to implement it for all of our own HTTP contents, and we have ability to do it reasonably and without any blocking over async on anything, because we already have the stream available for all of our contents. And in the little proposed API, you can see the methods, and they follow up the same pattern as the async methods, with a little exception. Little exception that the protected virtual method createContent.ReadStream, we decided to go with only one method with a default value for optional parameter instead of two overloads, because the two overloads would force the implementation to overload both of them. And this way, since it's only protected and not visible on the external API of the class, we think it's like more easier way to implement this way. Any questions, or do you want to know any details?
I mean, if this would have been public, we would have just added a public non-virtual create content reader stream without a cancellation token that would just call the other one, right? So like you wouldn't have to implement both of them. You would only have to implement one of them. But given that it's protected, I think I don't care. I think an optional cancellation token works for me.
Yeah.
I don't know how Jeremy feels about this.
Yeah, like I think so. Well, we said virtual methods shouldn't have defaults. I think we said virtual methods shouldn't have defaults except for cancellation tokens. So,
I see.
So it seems fine.
Okay.
And then ReadAsStream makes sense to me. It models the other APIs.
Yeah. Yeah, I was gonna say, why would ReadAsStream we do overloads instead of a default?
That's to follow, because in the HTTP client send method, we had the one method with default values, and you wanted me to do the overloads instead of it, because the async method had the overloads to be consistent with the async method on the same class.
Yeah, we basically said we want to model what the existing APIs are doing, and they were largely overloads, no defaults.
Yeah. Okay, that's a reason.
All right, then this was easy. Unless there's any pushback, I'll approve this now. I don't hear any, so that means and blocking I can remove now. Yay! All right, you're done for the day. Good job.
Yeah, thank you. Bye. Nice weekend.
You too.
That was easy. I wish everything's that easy.
I didn't even have time to get distracted.
I mean, if people would just accept when I say no right off the bat, then they'll be that easy.
Don't worry, we can.
And then .NET 6 is the exact same as .NET 5. .NET 7 is the same as .NET 6. Perfect.
No. Every now and then there'll be a crypto feature.
Feature in quotes, of course. All right, so who wants to talk us through it, Aaron or Fred?
I can take it unless Aaron wants to. So basically, the idea here is that as unmanaged callers only stands today, it's the top thing here, which is it has a public calling convention type. Now, what this means for C# is that we need to actually understand what calling conventions map to what set of mod ops. If the runtime wanted to later add something like vector call, for example, it would need to add vector call to the calling convention enum, and then the C# compiler would need to be updated to know how to translate from that to a set of mod ops. And the whole point of the API, the extensible calling convention API that we went around and designed, was that the C# compiler shouldn't actually need to understand what calling conventions are valid or how to translate them to a representation. It should just be able to take whatever the representation is and just say if it's equivalent, then it's the same. If it's not equivalent, then it's not the same.
So hold on, like I'm still somewhat lost. So basically, this is for function pointers in C#, right? So who puts unmanaged callers only on that? The developer or the compiler? So
that's the user would put unmanaged callers only on a method that they want to be only callable via a function pointer. So basically, when you put unmanaged callers only, you're saying that I want the runtime to actually create a stub for this that is calling convention cdecal or calling convention fast call or whatever.
I see.
And you can't call it directly from managed code. And it is convertible when you take an address of it.
Right.
That pointer is cdecal or fast call or what have you. And so in order to determine what the correct type of that in C# should be, we have two options. One, we can say that we don't do any help at all, and that we'll just trust you when you take the address of a function pointer, and we won't do any validation whatsoever. That doesn't seem like a great experience. So if we want to actually give an error, if you attempted to take the address of a function pointer that was cdecal and then store it in a function pointer that was fast call, for example, then we need to be able to have some way of converting between the attribute specified in unmanaged callers only and the actual calling convention of the function pointer. And so basically what this proposal is the current C# proposal for how the function pointer will actually look like is you specify a set of types. You say unmanaged, and then you would say callconf cdecal, and then maybe callconf suppress GC transition, or some number of types. And so those same types that go in the function pointer syntax would go in the unmanaged callers only in this array. And so the compiler doesn't have to actually understand anything. We just look to see whether or not the types are the same.
So I'm still not sure. So the array that the user passes in, where do these callconf standard call mod ops go?
They come from system. Well, so they're mod rect on the return type of the function pointer signature, or mod opt. I mean, on the return type of the function pointer signature.
So the function pointer itself is some type representation that is effectively comprised of mod recs, I guess.
Basically, so there's an existing call kind in the function pointer representation that has default, which is managed, cdecal, this call, std call, fast call, varargs, and then some reserved fields. But there's potentially even more calling conventions that the runtime would want to add. So the proposal for the runtime support is that we're going to add a new call kind, one more new call kind, something like extension, or that's the word I've been using for it, but doesn't. Some new flag to indicate that the calling convention should be determined by looking at the mod ops on the return type.
And so normally, mod recs and mod ops are part of a signature of something, so they can go anywhere, right? They can go on parameter types, they can go on the return type, they can go when you construct the type in weird ways. So are we sure that the flat array on the attribute is sufficient for all scenarios?
Yes, because there's only one place. So the extension that we're proposing only goes in one place on the function pointer. It's a mod opt on the return type before the ref if one exists.
I see.
That's it.
I mean, it is a bit verbose. I will say that, but I guess if that's what we do, that's what we do.
And then we were talking offline, Emo, that there might be a small change to the C# syntax. I hope it doesn't happen, but there is a small proposal that maybe instead of just having the types, we also have basically there's two pieces to this metadata, right? There's the call kind and there's the mod ops. Currently, the C# syntax only lets you represent the mod ops, and then we control the call kind based on the mod ops. There is a small proposal that maybe we have C# syntax to represent both the call kind and the mod ops, at which point unmanaged callers only would need to update to also represent both the call kind and the mod ops in order so we have that same ability to not care about what the representation is and just use the same logic for both.
Yeah, the only thing is like, so we basically still call it calling conventions, but like, is this the right name for the field now? Because if it basically supports to pass an arbitrary modifier, then maybe that should be a different name.
The types aren't arbitrary. They do have to come from system runtime compiler services, and they have to start with callconf. And we're going to error if you attempt to set anything there that isn't
I see. Okay.
things.
There's a note at towards the bottom that mentions the Roslyn compiler will be validating things.
Yeah, I mean, obviously in runtime you can construct that with what like if you write some IL, you can do whatever you want there, but
right. But okay, so it seems like any mod rec that we would add would still be called conf vector call or something, and then that would still be calling convention based. Okay, that makes sense then.
And it has to come from system private core lib. It can't come from some other library. Users can't define it.
Yeah. I mean, that makes sense to me. I mean, then also the name makes sense. I was about to say call conf is weird, but given that all the things start with call conf today, it probably makes sense to keep that prefix. Yeah, it's Interval API at the end of the day. Like, I'm fine with that. Unless Jeremy takes offense to that.
I actually had a quick question, Fred. So this is in order to allow multiple different mod ops onto the return, correct?
Correct.
If the common case, I assume the common case is going to be that you really only care about one, and in that case, we would still just refer people to the old syntax just because it's easier?
Well, so the common case is that you possibly only care about one. One of the things, for example, that we've been talking about is the ability to suppress GC transition for a managed attribute. And so that would go as a calling convention on the return. It would be call conf suppress GC transition. So, and the other thing is that we're trying to. It is a bit of a wart in that it's not super pretty syntax, but one of the things here is that it's the same syntax between unmanaged callers only and the function pointer syntax, and the compiler doesn't have to actually like care about what the set of valid calling conventions are. We just have to make sure everything matches, and so then the runtime is free to add new things without having to get a comparative compiler update, and everything kind of just works.
Sure. I guess what my question was coming down to is, does the original unmanaged callers only calling convention equals blah 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 API still make sense in the new world? And it sounds like the answer is yes. We wouldn't back that API out.
No, we would back that API out because that requires the compiler to understand the translation between this calling convention enum and the set of mod ops and call kind. And the whole point is that we don't want to understand that.
Okay.
And so do I always have to...
Oh, okay. I see that part of the API now. Okay, got it.
Do I always have to specify the calling conventions? Or is this optional?
I believe so. I don't... Aaron?
So in the function pointer spec, if I recall, there's you can just specify unmanaged.
Right.
And at that point, the runtime basically says, oh, I'll determine this based on whatever platform I'm running on. Like it's the implied on Windows. I'm pretty sure that's standard call in x86, and on Unix it's cdecl. And so we could say, yeah, there's going to be a call conv unmanaged, and that is equivalent to the unmanaged function pointers semantic keyword. But I think I think just not setting it is, yeah, use whatever the platform default is. It doesn't require anything.
That actually does make sense because it's the same as the C# syntax where you don't specify anything.
Right.
So.
Yeah. Cool. Yeah. So not specifying anything is completely legit. And to be quite frank, that is actually one of the reasons why we kind of re-examined the C# function pointers, because originally we were going to have, cdecl as a semantic keyword, and then we were like, that's very backwards looking because it's limited to x86 32-bit only. And so the idea is, in a world where 64-bit is the de facto or the most common case, why should users even think about this? So for right now, the only real interesting scenario where users would probably specify a call conv is if they're on a 32-bit x86 machine. That would be the only real reason.
We are planning on introducing another calling convention into the runtime that exists across different platforms, particularly on Windows, because of the way instance methods are handled. So that's the only one that would make sense off of x86 at the moment for the unmanaged callers only usage. Whereas the default would work in most cases otherwise, I believe.
Yeah, I mean, to me, it makes sense. I mean, like, if that's where we are, that's where we are. I think my only question was, if this is not optional, then we should not make it a property. Probably it should be a constructor argument. But if it's optional, then the shape makes sense to me.
Yeah, I would be very surprised how often this is used in other cases. Like, I mean, there are cases where it might be interesting, but that's definitely going to be the lower percentage. Not even considering the fact that this ideally will be used for a very small, a very narrow slice of the .NET ecosystem.
Yeah, that's famous last words, right?
Okay, so yes, I can imagine people abusing this and having fun doing something, but yeah, that's fair.
The amount of people who already said they love function pointers is scary.
They all live on Discord and they all know who I am.
All right, then seems reasonable.
All right. Thanks, everyone.
Thank you.
See y'all later.
Probably unavoidable. Yeah.
Wait, so just one quick question. Did Fred jump off?
He did.
Dang it. The one question that I had is I believe that there was he alluded to potentially adding something back to this API if we need to, depending on their conversation for function pointers. And I thought we were going to actually ask if we could figure that out. Like if we could do any small modifications to this API offline as opposed to spinning up another meeting.
Yeah, I mean I have no idea what this looks like. I mean, I assume it's another property with an array probably or something like that, which could totally be done over email. Like, I mean, it depends on how long it takes us. If it takes us 4 months, we probably don't remember the details. Other than that.
Okay, now. All right. I think that we're gonna get to consensus here next week sometime. as far as if we do need to add something small.
Right.
All right. So we'll do that online on GitHub or offline if we need to.
Yep, sounds good.
Okay.
Awesome.
Thanks all.
Thank you. And then I think we can just continue with regular backlog. So there's a few blocking ones that are still marked. Let me just pull them up. You say that? Okay, it is actually opening. Funny, I marked it and I don't know what it is. I believe we had a brief conversation with Arthur on this. Basically, the question was whether they should change existing behavior or whether they should add a new attribute, and I think we just said probably new attribute is fine. But I don't actually remember the details of this, so we probably need to make sure that Pranav is in the room so we can talk about it. Unless somebody else has context on the call, which I assume is not the case. Alright, then let's just ignore this one. I'll probably throw this in the same vicinity. Yeah, seems like we want to have Pranav in the room for that one. Dum 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 dum.
Did we lose our fearless leader?
No, I was just silent because typing is hard. Assuming you can still hear me.
Yeah, your video is just frozen.
Yeah, my video is like my CPU is struggling hard. So I'm just going oldest to newest now. And let's see how far we get. Yeah, who marked this one here? Oopsie. I guess I need to send an invite for this. Thought I did that already.
Yeah, we're actually not ready for that yet. I've been working offline with the EF team on this.
So what's missing here?
There's just some other like documentation that needs to be done first regarding all of this. It's just politicking and stuff. Nothing that should really concern this group too much.
Sounds good. Yeah, I'm just curious. Like, do you roughly know when it will be ready for review?
No.
But I guess what's his name again?
I guess let's unmark it. API ready for review.
Yeah, that would be my other
It's
suggestion.
not marked blocking, is it?
It's not.
Okay. Okay.
But yeah. I mean, I'll start an email thread with Shai and then we see where we land. We can probably set up something for 2 weeks from now and then probably will be enough. All right. Steven on the call? I think he was earlier, no?
Yeah, sorry, I'm here. I was on mute.
Do you know what this is?
Yeah, so in the Dataflow library, there's this TransformManyBlock, which is effectively a select many. You give it a delegate, and as input data comes in, it runs that delegate over the input data and produces some amount of output data. Some of the overload, and because it's producing potentially multiple things, the delegate returns an IAsyncEnumerable. And so there's the corollary, which is to have a delegate that returns an IAsyncEnumerable. So that's on the processing side. And then in terms of consuming output from various blocks, just like we have with channels where you can kind of asynchronously enumerate the output, there's a desire to do that with Dataflow blocks as well. So basically adding an extension method to receive all async from these various blocks with an extension method that allows you to await for each the contents.
Yeah, I would have used both of these in the past, so I like them.
Yeah, I agree. This seems pretty straightforward for the scenarios.
So I don't know enough about C# rules here, but like if I do async here, it will automatically create an IAsyncEnumerable?
It should, because of the yields in the block.
Yeah, I thought naively like the way that would have the rules is that you basically just, I mean, for backwards compatibility reason, I would assume that async here just means you return a task of IAsyncEnumerable. But I guess they didn't allow you to do that before, right? They didn't have yield and
Yeah,
async.
there's no backwards compatibility. Well, you couldn't have yield in the iterator before.
Gotcha. Okay. That makes sense then. Yeah, unless anybody has any concerns, that seems reasonable.
Sorry, I meant yield in a lambda, not yield in the iterator. That made no sense. But I think you knew what I meant.
Yeah, that's what I heard, I think.
Yeah.
We ready for this, Levi?
I'm still waiting for feedback from the internal document that I sent around, so no.
Okay, then let's skip this one. Anybody opinions on this? Tanner, maybe? Who marked it?
Yeah, this one is basically just requesting we add a new method to quickly check is POW2. You can do this using popCount, but in the case that popCount is not supported, there's a faster implementation that should be provided as a fallback.
That makes sense to me.
I think this is fine to add. I'm just curious, Tanner, are there places we'll use this internally? I seem to remember us doing checks for power of 2 in a variety of places, but I can't recall any off the top of my head.
Yeah, I believe there's at least 1 or 2 places where we could use it internally. At the very least, we've got similar checks already in the floating point parsing and formatting code.
Cool.
Array pool uses this on return as well.
Yeah.
Or could use it.
So popCount is not a hardware intrinsic, right? We just happen to, we basically always provide an implementation for popCount, right?
Correct. We've got both the actual hardware intrinsic, and then we've got the bit operations popCount, which provides a software fallback in the case that popCount's not supported.
Right. I think bit operations is a type we added recently, right? To hold all of the stuff.
Right, but correct. It also holds like leading 0 count, trailing 0 count, rotate left and rotate right.
Yeah, it seems like the right place. It seems like the right semantics. I mean, makes total sense to me.
Yeah.
Actually, I had a question on place. Like we have, like the POW function is on math. Does this not make sense on math?
Right. That was a topic that came up here. For one of the things that keeps coming up with math is it may not necessarily be the best place to continue exposing a lot of functions because you quickly get into overload resolution problems as you want to expand it in the future, given that it's trying to support mainly double, but also potentially all the other primitive types as well, depending on which operation it is. This is realistically...
So the argument, the argument for putting this on bit operations is not that it's power of 2, it's that we're checking to see if a bit is set like 1 and only 1 or none. Basically.
Right. And while it might be beneficial to have it on math and more discoverable there, I think the downsides that we continue coming into with math just push it over that edge into bit operations as being the better place.
Yeah, we already did math and mathf, right? And then it's a bit weird to have math.isPow2 with not even any doubles, right?
Yeah, the reason I like this on bit operations as well is because it is fundamentally a bitwise manipulation or bitwise inspection, except for the 0 case, which is special cased here.
Is there a reason we don't have short?
So you're very quiet.
There's no particular reason why we didn't expose short and byte, other than we generally don't expose explicit operations for short and byte, outside of a few specialized scenarios.
Short and byte would both upconvert to int, and that's fine on a 32-bit system, and I don't think we support any 16-bit systems, so there's no, like, on a 32, you don't want the upconvert to long. But since we don't have 16s, we don't need those smaller value types.
Right, and there is no explicit hardware acceleration for pop count over a
smaller version,
a 16 or 8 value.
Makes sense.
You are very quiet though, Eric.
Sorry.
All right, that was easy. Add API to get bit length of BigInteger.
Actually, related, should we add isPow2 to BigInteger as well because it is a numeric type, or is that kind of out of scope?
I mean, we generally don't do bit filling with BigInteger, do we?
Well, such an API probably wouldn't be on bit operations, it would be on BigInteger itself if we added it.
Right. I think that's out of scope for today.
It's already a public property.
Yeah, that would be
BigInteger.isPower of TWO.
Works for me. Okay.
Somebody was smart.
So this is basically just proposing a new method to get the number of bits that are in the BigInteger. This allows you to determine exactly how many bits are in it, which allows you to do other interesting tricks, mathematically speaking, with the BigInteger. It's currently expensive to compute yourself, and it would be much cheaper for us to do it internally, given we have access to members and data that isn't exposed publicly.
So this is the bit number of the most significant bit plus 1, right? It's not pop count.
Correct. This is basically length, but in bits rather than in bytes.
So what would length in bits be better than, or more interesting than bits in bytes? Sorry, than number of bytes? Isn't there basically just number of bytes times 8 then?
Not necessarily, because we may be using more bytes to represent the data. So for example, if you have the value 1. You're using 1 bit out of the 8 bits in the byte that's used to represent the underlying data. So this basically tells you how much is this going to need to grow by if I'm doing specific operations. Essentially, how much more space do I have in the current backing array?
I see.
Because multiplying two numbers, essentially the size is bit length of one plus bit length of the second.
Yeah. And then if you're adding, the maximum value returned is bit length times the larger of the 2 bit lengths plus 1.
I mean, it seems reasonable to me.
Yeah, so what's the actual proposal?
The actual proposal is this. Just get bit length.
Yep. They originally proposed a property, but given that this isn't necessarily always cheap to compute, it's fairly cheap, though. I propose to be a method.
Yeah, I was going to encourage it to be a method instead of a property. So I'm good with that proposal.
Do we have any like, we don't have any prior art for this stuff, right? The only thing we could probably do is maybe we should have get bit count rather than get bit length, because we have a get byte count already.
On BigInteger?
Yeah.
It looks like we also have public get length.
Great, so we're already very consistent in our use of terminology. I don't see get
We're
length.
also consistent with count versus length.
Are you sure? I don't see a length at all on BigInteger. Are you looking at the right BigInteger, or are you looking at the mono version?
I think I'm looking at the right, but I'm looking at source.net, so maybe I'm finding something I shouldn't be able to see. Maybe it's not in the ref. Yeah, because the get byte count, yeah, that one took a parameter, because clearly I added that one because it was the day that I said is unsigned instead of unsigned. Because that one needed to know if it needed the padding or not. So it's not about the number, it's about the encoding.
Yeah, it looks like there is no length property on publicly exposed.
Weird.
In that case, I would almost say get bit count.
Jeremy, you're looking at XML, XSL, XPath convert BigInteger.
Am I? Like, it says it's system.number.BigInteger. I think this is the thing driving like hex pretty printing, though. Not.
I think.
Yeah, this is it's a public method on an internal type, which is why I hate when we use the public keyword on the internal types. All right.
So I wasn't wrong when I asked, are you looking at the right type? Because BigInteger, I've consistently looked at the wrong type.
Yes, I was looking at system.number.BigInteger, not system.numerics.BigInteger.
System.number, who does that? That's just outright evil.
Yeah.
All right, then. Yeah, any objections to what I said? Or does that make sense to people?
I don't have any objection to get bit count.
Yeah, I mean, like, certainly I feel that bit length is a more normal term, but that may be crypto-ese talking. So,
I mean, I feel like the byte count is more related to maybe serialization, and the bit count is more related to arithmetic. So I don't think that they need symmetry here.
I would also worry that bit count as opposed to bit length suggests it's pop count instead of most significant bit.
I was just about to say that as well.
So what was the last part that clipped out?
That when hearing somebody else, or when hearing Corey say the word just now, when he said get bit count, I heard pop count. So how many bits are set to 1 as opposed to what is the index of the most significant bit. So I feel that bit length is the length of the vector, whether they're 1s or 0s, and bit count feels more like how many of the bits are set to 1. That's what my brain heard.
Works for me.
So I'm back to get bit length.
Is there a reason this wouldn't just be a property bit length? Is it expensive?
It can be.
It's not necessarily cheap, and someone could implement it very poorly.
So what does get parts from manipulation do? Does anybody know?
So BigInteger is a little bit magic in how it works. It has an array as a backing type, but that array might not be used. It might instead use a special, I think it's a long value, which contains the sign if the array is used, and otherwise contains the low 64-bit value of the BigInteger. So you have to do several checks to see like which bit of data is actually in use by this BigInteger based on the size, and then you have to do the appropriate call in computation based on that.
Like you wouldn't really want to you wouldn't want to have, val dot bit length as a property in a while loop or a for loop, because it does more work than you would want it to do in the loop scenario. So it's better as a method. It says call it once and remember the answer.
Yeah, I mean, it makes sense to me. I mean, like, it seems, generally speaking, intuitively, it needs to be an ON operation, right? I mean, the n might be small, but like fundamentally, it's however wide this guy is, right? So.
Yeah. Well, the thing is, fundamentally, it's a log2 operation that returns an int instead of a double.
Right.
Which implies it could be called log2 int.
Yeah, well, I mean, but it's not log2 truncated.
It has to handle like
seal
0 and stuff like that.
Yeah, it's seal of log2, basically.
I agree with that. All right, so let me just post my comment then.
Can we jump back to the isPow2 quickly?
Uh,
Sorry. Like the BigInteger having is power of 2, and then this being is POW2 kind of sort of rubs me the wrong way that they're inconsistent.
I mean,
Yeah,
if they're on different
for BigInteger,
types,
we spelled out the 2.
If we spell out power OFTWO.
yeah, we say is power of 2, and here we say is pow 2. I mean,
IsPow2 is more consistent with what some other systems call it, and with how the terminology on math is regarding POW and 2. I would say that BigIntegers is the odd one out here, actually, system-wide.
I agree with Tanner. Bit operations, in fact, already has an API called log2 with a numeral 2 instead of the word 2 written out, even though it's a log base 2 API.
yeah, I mean, I guess maybe I'm just weird, but for math operations, I always, it's probably the way we started because we happen to mirror the C names, but like, I personally have no objection to that. I mean, I hear what you're saying, but to me, consistency between types and then drastically different areas is not ideal, but it's also not terrible. Like on the same type, yes, but on different types, I think
In
that's
the same
okay.
namespace.
Yeah, I give you that.
Okay, I just wanted to call it out that it's doing the same things and we're calling it different things.
Right. I mean, it's also just a sheer shape, right? Like you call an instance method rather than a static method. I mean, it will never look like super clean, right? If you actually happen to process ints, longs, and big integer in the same method, right? But I guess, yeah, I think to me it's more important that within bit operations the name makes sense. And I guess is power 2 would work, but is power of 2 where we literally spell out 2, that would seem weird. All right.
Yeah. I think that based on the fact that we already have log and then the decimal digit 2 means isPow2 matches the type better.
It's funny how the math stuff gets a pass for our design guidelines.
Yeah, I mean, it's not just math. I mean, it's always the context in which you try to make an API work, right? So crypto is another area where we have sort of given up because it's the prior art is overwhelmingly weirdly named, and so if you add one more thing, it's just like, well, the naming conventions in crypto are this, and so we just stick to those, right? And that's the same thing with math. I mean, if we were to design system.math today, we would probably use different names, but even on the hardware intrinsic side, we basically said, like, look, we can't give everything super nice names because we kind of still have to somehow use the terminology that is used by the manufacturers of the ISAs, and sometimes they're just weird.
And I'm also not convinced that your statement, Immo, on we use different names is correct. When you look at calculators, LaTeX, and basically any mathematical use of the terms, no one uses power. They use POW. No one uses log TWO. They use log 2, log 10, etc. In the mathematical world and in the context that other programming languages work with the math libraries, they overwhelmingly use the shortened names here.
Yeah, I mean, I would never say
use...
spell out the numbers, but I mean, power of 2 seems reasonable, or power 2 seems reasonable as a name, right? But yeah, I mean, I don't disagree with you. Like, I think we have sometimes given abbreviations a pass if it's effectively an industry term, right? And I guess for power, I can be convinced that that's the case.
Okay, I'm satisfied. I just wanted to make sure everybody was.
It's okay.
No,
it's
a
Friday.
Good point, though.
It's bike shedding time. No. I think it's fair. I mean, the framework. I mean, we try to be consistent, right? But we also have to recognize that total consistency is not achievable, and so we need to do the second best, which is local consistency to a certain extent. All right. So then, this one is done. Is this ready, Levi?
Speaking of bike shedding, yes, it actually is ready. The general idea behind this is that there is a desire, at least by me and a few other people, to introduce a Roslyn analyzer that says, like, hey, you're calling an API that you would normally need to use unsafe code for. Like, you're basically calling an unsafe equivalent API, but we didn't put unsafe in the name, and people don't necessarily know that it's unsafe. So the analyzer would say, like, you have to call this in an unsafe block, even though you're not technically using pointers. In order to identify such APIs, they would be attributed with CallerMustBeUnsafe. And that's this proposal to introduce this attribute. This was a little contentious just from the point of view that, well, what does unsafe mean? Like, is private reflection unsafe? Stuff like that. And the answer is yes, but I think for this we would want to limit it to APIs which are doing pointer-like things. So a good example of that would be like memory marshal.createSpan ref of t comma int. Like there is quite literally no way to represent that in type safe C#. You're quite literally going into an unsafe world when you call that API.
So it makes sense to me, and I mean, since you brought up analyzers, I think that would address my other concern, because basically almost all the things that you could do like this, we already have kind of APIs for, and we couldn't force that if it's a compiler feature, right? But if it's an analyzer feature, we could totally like start warning when people do that, right, and require unsafe. Would we do that though, or would you only use it for new attribute for new APIs?
If we were deliberate about where we added it, we could consider attributing existing APIs. CreateSpan and CreateReadOnlySpan were two examples that are listed here. I wouldn't attribute types like unsafe, unsafe.as, stuff like that, because the word unsafe is already in the name. Like you literally wrote the word unsafe, in your code. That's fine.
Yeah, I guess.
I don't know. I kind of feel differently. I feel like if we're going to do it, we should do it on anything that, if there was language support for, would have required unsafe. But at the same time, I don't see any way that this analyzer can be warnings or errors by default. Like at best, we would want to make it an info by default, and then we go, and annotate everything which should really be in an unsafe block.
Yeah, I would say the same. My thinking is that even on something like unsafe, you can remove that unsafe keyword and hide it by using static system runtime compiler services unsafe, and then you can just call like skip init. In which case, having it even on those types is beneficial. Given that it's going to be an analyzer, the analyzer will likely not be on by default. Should this be callers should be unsafe?
I don't have a strong preference, honestly.
I mean, we could decide that we want to turn the analyzer on by default in 6.
I don't know. I feel like so two things. First, I think you should describe what the method is doing, not the requirement it places on the caller. And then the analyzer is choosing to basically say, as a result of that, you should really be in an unsafe block. So for me, it's not caller must be unsafe, is this lets you do unsafe things, whatever that name is.
Callee is unsafe?
Yeah, the equivalent of that.
Yeah.
And then for me, I have trouble imagining a world where we ship the analyzer to customers with it anything more than info by default. We would probably turn this on in .NET Runtime as, warning, which basically makes it error by default. But in general, I feel uncomfortable about being able to put this on things and really affect the semantics of the language. Because anyone could add this attribute to anything, and all of a sudden you're getting warnings or errors from the compiler saying this is unsafe when it's not. At least that's my mental model.
What about for new code? Would new code be a warning instead of info by default? I'm sorry, for new APIs. If we attributed this on new APIs, would that analyzer ship as on by default?
I don't know. It seems like a lot of noise. Like for someone who doesn't care, it seems like a lot of noise.
I mean, that's kind of the concern, right? It's like the question is, what would that mean? I mean, so to elaborate on Stephen's point, like my other concern is if you say unsafe, what does it really mean? I mean, usually it will mean that the caller has to be in an unsafe block, because it doesn't make much sense to annotate the calling member itself, because you probably don't have pointers in your APIs to begin with. And then the question is, will the compiler ever say something like, you're using unsafe, but you're not using any pointers? That's actually somewhat like it's not necessary kind of analysis. And then you get conflicting warnings that says one party says you don't need it, the other party says you need to use it. And then really the question is, the fixer would be relatively simple. You would just surround the code with a block that says unsafe, maybe update the project setting to say is unsafe or whatever, right? But that's, as Stephen said, right? I mean, it's probably an easy fix in the sense that you control your way through that, and hopefully it's not that many places in your code base unless you're system.runtime or system to private or call it. And so it's probably fine for most of our customers, but it does seem like one of those things where if you care, you care, but if you don't care, you really don't care, right? It's, you just make me write syntax to do the things I already do.
This seems like a case where we're enforcing our own opinions on a large number of people, and I don't think we have the right to do that.
Well, it's not necessarily an opinion, given that, like, memory_marshal.createSpan is unsafe. It bypasses language semantics, and if you're using it, it's very possible to screw your code up easily. But at the same time,
it's the opinion that you need to be using the unsafe keyword in C# to annotate it.
Yes.
Well, it could work like skip locals init, in which case the analyzer doesn't say that the actual code block needs to be unsafe, but rather the compilation should have been compiled with allow unsafe code.
Right. Go ahead, Levi.
Oh, I was going to say, like, the definition of this basically would be that the code that you're about to write is not verifiable. That's really what this is tracking. It doesn't have to be a pointer per se. It's just anything you're about to do that's not verifiable.
Right. And is there anything that you would already be wanting to put this on that is something other than unverifiable memory? Because Steve's earlier point is you're painting the action that someone should have for the call context as opposed to describing the problem. So if we made it the positive assertion that this is non-verifiable memory operation or something, then now we have an analyzer of, hey, tell me if I'm making non-verifiable memory assertions, and it's like, okay, well, here you go.
Collection marshal.getSpan from list is one example where I think this would be applicable, which isn't unverifiable, but it is unsafe in that you may be pointing to an array that no longer backs the list anymore.
Right.
Yeah, but the same thing can be said about array pool. Like, would we add this to array pool.rent?
So according to Jan, yes. But
right. So
I'm sorry, I shouldn't have put words in his mouth, but he did say that he sees the array pool as a malloc equivalent.
Right.
Sure, but now we're going down a path where pretty much you can't write code without putting unsafe around every method. I mean, like, I'm exaggerating, but that's the path this is headed towards.
Yeah, I wouldn't put this around array pool, honestly. Like, that ship has sailed as much as I want to.
I mean, to Steven's point, though, I think one thing that the analyzer does do is it basically forces an opinion on how the caller has to annotate the fact that they do something unsafe, right? Because, I mean, it really doesn't change the semantics of the code, right? It just says, well, you can already do it today. It's unsafe. It has the behavior that it does. But we want you to record that fact in your code base by surrounding it with an unsafe keyword or something along those lines, right? And that's almost a coding. It's almost like a coding guideline that you force on people, right? So in that sense, I would agree with him.
The reason for that, by the way, is because it turns out there are a lot of enterprises that require strict scrutiny of code that uses unsafe blocks. Those enterprises allow the code. It's just it requires, for instance, several people to sign off on it. What I've seen in practice is that because people don't have to apply that, they are more lax about calling some of the APIs that we've provided in .NET Core 3, not realizing that, hey, like, you really should have gone through your proper review process here. Because you didn't have to write the unsafe keyword, you might not know that what you're doing is unsafe.
Sure. The groups you described, though, are the minority of developers in the world. That's not to say they don't matter. They absolutely do. But enforcing an opinion on everyone else by default is a problem.
I mean, I will say, though, let's turn this around. Let's say we would not apply this attribute on anything that already exists, right? Let's say we would only use it for new APIs. I mean, we have stood in meetings where we all said we wish we could force the unsafe keyword on certain APIs, right? And then that would be a way to do it, right? So I guess I try to separate the, what do we do for existing code versus what do we do moving forward, right?
Yeah, but I have trouble with that distinction. I mean, some of the worst offenders are things that have been around for 20 years.
So I agree with
Marshal.read. Marshal.write, right?
But I guess maybe part of it is also because people know that anything in system interrupt services, and especially anything called Marshall, probably is something unsafe. Versus
People don't realize that. Like, people really do not realize that.
Are we gonna require this on every single DLL import?
Sorry?
Every
Oh,
DLL
no.
import has the ability to do unsafe stuff.
No, like if you're calling an API that takes an int pointer or a void star as a parameter, like, you are clearly doing something unsafe. Like, clearly. The thing is that the APIs that we provided on types like memory marshal don't clearly delineate that, which is why people don't realize that they're dangerous. And this was attempting to solve that.
My point is, I can write a DLL import with no int pointers, no pointers in the signature, just basic things, and screw up memory way worse than any of the things that we're attributing as unsafe.
Yeah, but people don't do that in practice.
We also don't publicly export DLL imports. In the framework itself, we'd only be putting this on members which we publicly expose, which would qualify under that unsafeness.
Is this not going to be a public attribute?
Well, it would, but... Oh, I guess you're asking what would our public recommendations for applying it be then?
Right. So the recommendation that I would give for applying it would be, this API allows you to do something that is not expressible in type-safe verifiable C#.
I guess one thing to drive this list would be, can you give us a number of, like, a list of APIs you think qualifies? And then also, I guess, a short description of what new APIs we would apply this to, and also maybe list some examples that we would not apply to, right? I mean, to me, it's like the attribute name probably needs to change. We already talked about this. I can see the analyzer being available for the reasons you stated. I can even see us annotating existing APIs, so long the analyzer is off by default, and the people that really want to get this can opt into that. That's also fine, in my opinion. But I do see the problem that Stephen paints, which is it's not a clear-cut thing, right? So we would have to be somewhat consistent about how we use this, because if you live in a world where a third of our APIs end up having this attribute, then we failed, right? It needs to be somewhat of a very rare case, similar to unsafe today. Otherwise, it really fails at its purpose. Because then you do the reverse. Then you train everybody to ignore unsafe, right? Which is not the way you want to do this.
Okay. Yeah, the list right now of APIs that would qualify would be basically everything on the unsafe class, almost everything on memory marshal, and unfortunately arraypool.rent. And the reason that arraypool.rent qualifies is because as an implementation detail, it calls gc.createUninitializedArray. If it didn't do that, it wouldn't qualify as having this attribute.
So then GC createUninitializedArray would also qualify.
Yes, it would.
And
because it's not something you can express in type-safe verifiable C#.
And anything that we create arrays with that we then hand out in one way, shape, or form to user code?
Yes.
Which is probably an obscene number of places.
I would hope that we don't pass uninitialized array out to user code all that often.
Well, anywhere we're creating one and calling stream.read, stream.write.
But the create uninitialized array, if I recall correctly, if it blah 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 or contains blah 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 reference types, that still clears it. The only time that you get garbage in the array is when it's all blittable types. So it's not dangerous. It's unexpected.
It bypasses the constructor, and when you bypass a constructor, that's non-verifiable.
Reference types are still forced zeroed always.
Yes, but there are structs, such as those that wrap int pointers, that are not zeroed.
Yeah. Right, but that's just splittable types, like Jeremy was saying.
So, yes, but the fact that they're not zeroed is something that could not have been done in C# without using unverifiable IL.
Right, but if you use an array pool of any kind, whether it's a custom object pool or you use arrayPool.create or whatever,
Mhm.
if you have a struct that has an intpitter in it and you're reading it a second time, like intpitter is the safe version of unsafe code, right? It's the moment that it's there, unless you yourself know where the value came from, it's semi-untrustworthy. So
That's not correct. So for example, if I have an array of runtime method handle, as an example, runtime method handle is backed by an int pointer. At least it used to be. I don't know if it still is. And then I try invoking a method on it. That method is guaranteed never to AV unless the original array was created via create an initialized array. That's the one and only time you can ever shove a bad object in there, because you never would have been able to instantiate an invalid handle in the first place, which means if you can never instantiate it, you can never assign an array element to that value.
So private int pitters as opposed to publicly settable int pitters.
Yes. Okay, so but it sounds like there's still resistance to this then. So I probably don't want to bike shit on this too much so that we can get to other stuff. Okay.
Yeah, I mean, I think that what would help is the what's, the what's and the whys, because that would help us decide how many potentially different attributes we want for different analyzer levels and what state we want them to be in. And then some of them would be like, is there a way that we could figure out how to make arrayPool.rent where it would only trigger, or where it wouldn't trigger for the primitive types, because the most common array pools are byte and char. Those are
I opened that issue and it was closed as won't fix.
What issue?
I opened an issue saying we should only clear for things like byte and char, and that issue was closed as won't fix.
No, but we could make the analyzer say that array pool. I mean, we could explicitly exempt it if it's array pool byte and array pool char, if that's the concern. So we could slap the attribute on it and tell the analyzer that these two specific generic instantiations are safe.
Okay, so an analyzer rather than change the array pool implementation.
Right. Well, because I think that largely what we're talking about was assume that all the code stays the same. What attributes and analyzers can we add to help people write better code?
Yeah.
Or at least be aware of the code they're writing. And array pool byte rent is dangerous because you may not have a unique reference to the array when you think you do, but it's not dangerous in the sense that you're going to go into that you're going to do AVs.
Right. You're not going to AV. It's just you could end up reading memory that you should not have had access to, hence unverifiable. But something like the array of runtime handle, where now you're getting uninitialized int pitters that are just getting dereferenced later, would be an AV, and that's, or anything else that has a hidden int pitter that just gets read by native code. So, but yeah, so I think with what's and whys, it makes sense. There are definitely things that I recall being like, man, I want to just add a void star ignored to this just so it requires the unsafe keyword, but I don't remember those off the top of my head. Sounds good.
So is this a fair summary, what I just pasted?
Yes. Yeah, and I agree. The naming, people did have problems with the naming, and I understand that. It's if we want to say that it's unverifiable, then the name should reflect that. If in fact that is what we want to say it is.
Right. And then depending on what things we're applying it to and what, like, say we end up with 3 different attributes describing 3 different levels of unsafety, and we're like, okay, maybe we do feel that not a whole lot of people would be creating a span from a ref and account. Maybe we would be comfortable go ahead and turning on that analyzer as warning by default, but that would be a discussion that we'd have when we have the list. Steve may just say no anyway, but I think
and no is also a valid option. Okay. Cool. Thanks.
To be clear, I don't say no. I just discuss.
Yeah, I say no.
So it seems like this was filed with ready for review. So, does anybody know what this is?
Yeah, it's you have an incoming sequence and you're reading everything until a delimiter. So say that you're looking for a comma. Yeah. Oh, I'm sorry. You're looking for a comma space, for instance. This would read until it finds that, and then it returns back to you what it read.
So somebody in chat just said we rejected similar APIs before because it allocates across spans. I'm not
That sounds right.
sure. Why would we allocate across spans?
Because the span it needs to return, like the false cases become weird. Does it mean it didn't find the delimiter, or it didn't find it in a single span that it can do a slice of, or does it have to allocate? I think the problem is the implementation as proposed would allocate a temporary array, copy the stuff into it, and then emit a span to that array. And then there was the big, like, wait, this looks like a non-allocating operation that may be allocating every time.
Oh, because the sequence is disjoint, right? Yes. I get it. I'm like, why would you ever have to allocate if you just return a read-only-span? But yeah, if it's disjoint, then of course.
I mean, we already have a TryReadTo API on SequenceReader. Does that allocate? Like, I think if it's consistent, so long as this one is consistent with that one, it would be no different.
I think we talked about this before, and I think we said, like, yeah, the chip has sailed on this API, but it doesn't mean we should add more APIs like that. I mean, that was a discussion we had before where I think I'm more in the David Fowler camp where I would be like, yeah, allocate. I mean, if you're allocating rarely enough, it's still probably fine.
Yeah, there is an allocation. If the span exists across multiple segments, it allocates a brand new array and then returns the span to you.
Yeah, because there's the delimiter one. It looks like there is one, and it outs the sequence. Sorry, so there's TryReadTo out sequence, comma delimiter, comma optional boolean, which is not the way that it should have been structured, but it's already public. So I think it's outing the sequence, and then you can ask the sequence, are you a single span, and get the span, and if not, then do the complicated things. I don't see the value in making more. We create things for you that are much more potentially much more expensive than they look.
That makes sense.
I agree.
Yeah, if we did expose this, we would have to take a parameter that says, I allow you to make a copy if necessary.
Yeah, but then that's either bool throw or it's bool make false ambiguous.
Yeah, and now you start returning an enum. Yeah, it gets complicated.
So
I think the rationale why Fowler wanted this was because they will have to allocate anyway. And it's like, well, don't make me write the code.
Not necessarily. Like if they already have a buffer and they call the TryReadTo, which produces the subsequence, then they can take each of the individual segments of the subsequence, copying it into their buffer, and that was never allocating.
Yeah, that's right. I think we also had a discussion before whether you can pass in a scratch buffer or something, right? But then the question is, what if the scratch buffer isn't large enough, and blah blah blah, right? Like that's
right.
Fair enough. Okay, so then let me.
I want to say part of it too is a performance optimization because outing a span is cheaper than outing a sequence per the implementation, I think.
Actually, I fucked up. Hold on. That is the correct order.
It's not much bigger if it's a single span, I think. And then if it is across, then it's still probably cheaper to do the sequence than the intermediate copy.
Yeah, if it's across, you definitely, then it's definitely cheaper to do the sequence.
So we okay with that as a justification for closing then?
Yeah.
All right.
Well, I would probably say an API that might allocate unexpectedly, especially on a type that whose entire purpose is to avoid allocations.
Typos, but hey.
Meh.
Good enough. All right, then. Spicy. Something says when Levi has opinions on this.
I had commented on it that I think the operations are actually going to be more expensive than most people think. Trying to see where it was marked as ready for review.
It was filed as that.
Oh, you know what? I bet when it got moved, when the issue got moved between repos, I think it got lost at that point.
Oh, that's right. Yeah.
So this would only be expensive in the case where you cross two sequences or two spans, right? And that's likely going to be uncommon considering that everything except for float and double is going to be no more than 20 characters.
There is a weird boundary condition where you call something like parse int and then you consume the entire first span. Now you have to inspect the first byte of the second span to see if the integer would have overflowed.
Yeah,
Right.
but I think per Tanner's comment, I think that would be just as rare.
Yeah, like outside of float and double, you're not going to get more than 20 digits that you're really going to have to process. And for float and double, that's no more than 112 and 768. But those are extreme edge cases that realistically no one describes values that precise.
But what's the alternative? Like if I have a read-only sequence and I want to parse out an int, what do I do differently from what this method did?
What I would say at that point is like, if you should really read to the token delimiter and then get the entire span up to that point and parse that span as an int in one shot.
But that's essentially what the sample code here is, right? It's if it's a single segment, defer to the other one, and if it's not, then copy out more than you would need, and or copy out a number that is guaranteed to be too big, and then move on.
So I think my observation with ReadOnlySequence has been that if you are parsing it directly in small chunks like this, you're going to have bad performance. So I guess I wonder what the point of these are. Like it would almost be better on SequenceReader. unless these are purely for convenience. But I'm trying to think of where I would use these, and I'm kind of coming up blank.
Yeah, and that's my other question. So why would you not use SequenceReader? Because that seems like the most straightforward way of doing that, right?
I guess you would use these if you know that there's just a single int to parse to pull off a header or some sort of envelope from your sequence, and you're not doing a full parse of the entire sequence. It could be a little more convenient in that case.
Yeah, I guess that's my question. Like, is it like what would I mean? You could still have a sequence and you have a sequence reader, right? You don't have to. But if you use a sequence reader, you can no longer use the sequence because it's basically owning that at that point. Like, I mean, my guess is that's the scenario that they're in, right? Because what they do is they parse HTML, but then they parse in the large chunks, and then they pass the large chunks to the individual worker methods that then do whatever sequence reader stuff they're doing, right? And so in that sense, I can see that, but it also seems, somewhat rare-ish, right?
I feel like I would push back on this and say, show me where you're actually using this. Show me the scenarios, because I just don't. I feel like anywhere that you would use this, you would probably want to optimize later on and stop using it.
Yeah, because I'm looking at the sample code that David wrote earlier in the issue description, and that sample code should actually probably not be using UTF-8 parser, because UTF-8 parser will actually stop when it sees invalid data. The behavior that he wants is actually take this entire buffer, try to pull an integer from the entire buffer, and if there's anything whatsoever left over, fail. Basically, he wants int.parse because he has already segmented the buffer.
Well, I mean, his else case looks like he's expecting the stop when you hit a terminator. The fact that he copied into an overly big buffer.
What I'm looking at is the comment on October 30th, 2019. There are lots of them. It's the one that's 2 or 3 under what's on Emo's screen right now.
Okay, because this top one looks like, but he is looking for what the behavior is. I mean, he has a problem in that he's always reading 128, even if he didn't allocate into it. But and with skip locals in it, he's getting garbage. But
that honestly, looking at the sample code, that kind of is what Corey was saying. Right now, you're basically parsing a lot more than just, basically a minimum, right? And to really use.
What I would probably want is, if they intend for this to be used in Kestrel, I would probably want for them to create the methods themselves on a helper class, see how it plumbs through their own code, and then if it makes sense for their scenarios, then hand it over the wall to us. Especially if the implementation is literally just going to be try pulling out a span. If it succeeds, then do some other stuff.
Is that your cat, Levi?
Oh, I'm not muted, sorry.
It's awesome. I like it. It's just like, like I was thinking the whole time somebody has a speaker that sounds exactly like a cat, and then it occurred to me that we actually probably have a cat on the call.
Yeah. They're a bit afraid because there's construction going on the house right now, so they're curled up in front of me, trying to be safe.
I love it. All right. Yeah, I'm still not entirely sure how this is different from SequenceReader, though. And we have sequence reader APIs that do that, right?
I don't know if we have sequence reader APIs that do things like read int, read long.
Yeah, we don't have that.
Not in the same way that these do, rather.
Really? I mean, I could have sworn that we reviewed this. So then how are you supposed to do this then? Basically get a span and then write all the boundary conditions yourself?
The suggestion that was brought up earlier was if you know that an int, for instance, can't be more than 10 or 11 bytes, then pull out 10 or 11 bytes, run it over UTF-8 parser and see what it gives you back.
That's right. Looking at sequence reader, it doesn't seem to have any of this. Yes. Sequence reader seems to be more like, you know, seek to and then give me the buffer.
But that's also why I was wondering what the scenario is, because if you're going until you hit a space or a new line or whatever token anyway, at that point you have a complete buffer that you expect to be in its entirety an integer, for instance, and you want to parse the entire thing as an integer, and that's not really what UTF-8 parser was meant for. Like, it can be used that way, it's just kind of weird to use it that way.
Yeah, I mean, it seems like that's a discussion we should probably have a follow at this point, because none of us feel we are actually sponsoring this API. But it also seems like there was a lot of discussion on it already, so putting this
We were
back.
discussing alternate ways to handle parsing, and it's not super relevant to this issue.
Yeah, some of the discussion here was bike shedding, how we can most, in a high performance fashion, implement it.
I mean, I guess my question is, like, if we don't have an API like this, what do we expect users to do, right? And it seems like the way we expect people to do it is to say, well, your sequences better be large, as in the buffers are better be large, and then you basically process 4K or 8K buffers, and they're just single spans, and we have parsing APIs for those. And at the boundary, you have to decide what to do. You basically have to allocate some temp stack a log thingy, and then handle things there. And yes, you have to do this for all primitive types. What things you care about, right?
Well, that's why I was thinking that if they want to use this inside of Kestrel, then they could do these methods themselves, see how it flows through their code base, and then if it ends up being useful for those scenarios, then bring it back.
So we can ask them, but my gut feel is that's what they have already done.
But we see no evidence of that. That's the problem. Like, we don't know what their implementations are, how it's actually used through their code base. Like, the code that David gave is a hypothetical rather than a we tried this.
And I'm pretty sure I put in an example here of how you could accomplish something very easy with just a single extension method.
So what's the primary concern with this API then, perf?
It will encourage bad parser design.
Part of the same reason that we don't want people calling like memory.span in a loop. You might think that you're doing something pretty efficient, but in reality, your performance would be better if you did the naive thing.
So is this fair then, as a statement? Parsers should really be over spans, not sequences.
Yes.
I mean, to me, the question really is, I mean, perf is also very relative, right? I think my concern is, are we optimizing for the right set of people here? Because, I mean, just because you could be faster in principle doesn't mean that we need to make everybody write a lot of boilerplate code, right? We could still say, yes, you still avoid allocations, which still gives you a lot of perf gains in the general case. And yes, your parser might not be as fast as it could be, but that's still better than people doing the super naive thing of just basically, two arraying their stuff and then working over the data structures, right?
I think that naive thing for many scenarios might actually be faster.
Well, I mean, but there's two different things, right? There's throughput for one operation, and there's throughput once you have a million of those operations, right? And so if allocations is one of your biggest problems, then two arraying clearly is not better than avoiding them, right?
It has to be measured, but if you have if you allocate a temporary array and then do a bunch of very quick operations on that and let the garbage collector eventually reclaim it, depending on your scenario, that might actually be faster than doing an expensive cracking open of a sequence reader.
Fair enough. I mean,
multiple times in a week.
I mean, that's the old discussion, right? Like GC, how fast is it, right? And I think that's where Jan and David are on opposite ends of the spectrum. But
and honestly, like if we get something like escape analysis too, then a lot of the problem goes away anyway. But if we're marketing SequenceReader toward a type of developer who wants really, really high performance, really low allocations, it's the same reason that we said like maybe TryReadTo isn't the right idea. Like it's going to encourage you to use patterns that we would rather you not use.
Yeah, to me it seems like that seems to be the primary thing that we need to do is bounce it back to API needs work. Post a comment.
Yeah. So here's another way that I see this. Like we would never have a UTF-8 parser that takes a read-only memory of T. Because at that point, we're now forcing you to crack open the memory, get the span, and then operate on it in a loop. Because we would never do that for memory of T, that gives me reservations that we would want to do it for sequence reader of T, because sequence reader is backed by memory, effectively.
Yeah, I was thinking of a similar argument.
All right, then I'll now see cover, and then we see what the response of this is.
Yeah, I'm not opposed to actually doing it if the evidence shows that we should do it. It's just without that evidence, we're kind of flying blind here.
Yeah, I mean, again, like my gut feel is that it's not that you're wrong. I think that it's just that there is a continuum in the middle, right? If your primary concern is you reduce allocations and you have a large enough system, you want it to be convenient for people to do so, then I can see that argument fly. I mean, you're basically saying I'm willing to trade some CPU cycles in order to reduce allocations because I know that in the long run, allocations is more important than absolute throughput, right?
Sure, but if we start saying it's a continuum, then we shouldn't have a single type, such as sequence reader, that exists along that continuum. That type should exist at one end or the other of the continuum. Otherwise, it's hard for developers to reason about when they should use it.
Sure, but I mean, I guess all I would say is that with span, we've kind of are in this half-pregnant state already because we give. I mean, already now we have basically 12 different types effectively to do the same thing, right? I mean, we have 3 different kinds of spans, we have 3 different kinds of memory, we have arrays, and they all more or less do the same thing. They're all a representation of a buffer in various shapes, right? And then we added sequences on top of that, and so in that sense, we already have that continuum whether we want it or not, and people have to choose the right type for the right job. And I think the question here is just, can we make it so that one of those types you can use, for much longer on the continuum than just on one particular spot on the continuum, which makes it easier to write that code, right? And I buy that. But yeah, I don't have strong opinions one way or the other. I'm just trying to
Sure, that's fair.
All right, so then channel reader. Steven, are you still with us? Doesn't sound like it.
Yep. No, I'm here. Channel reader TryPeek. Can you hear me?
Yep. Perfectly fine. You're walking your dog, probably.
I was. I'm no longer. But I am outside. So channel reader has various methods for reading: read async, try read, read all async, etc. And there's been a request to peek to see what's there. So that's basically what this is. Try peek. I'm not sure there's more to say than that.
So is it going to have a reasonable default, or is it going to throw derived types must deal with this?
It will return false.
Oh, right. Gotcha.
Yeah, I assume that is the default implementation up there on the screen.
It looks like there's no non-try equivalent.
Correct.
So the downside of having the default implementation return no is that if I call TryPeek and it returns false, is it because there was no data or because the reader didn't support it?
Right. So we can support it on all the built-in ones. But if someone else had a custom reader, hadn't yet overridden this or just never got around to it, someone calling this doesn't know the difference, as you said, Levi. That's the fundamental downside. Unfortunately, there's no existing API that we can build it in terms of.
Yeah, can we, or should we add a can peek for optional feature pattern?
We could.
That would let someone understand if can peek is true and TryPeek returned false, that means it's empty. If can peek returns false, then don't call TryPeek. We could also make the default virtual of TryPeek throw a can peek was false, why are you here? But I'll leave that up to you.
Yeah, you can. The thing that I struggle with in some of these capability, can whatever APIs, and is I don't know, like if I'm writing an algorithm that relies on peek, I don't know what I do with the can other than like my component doesn't work when it's not available.
Right, but if you were writing an algorithm that depends on peek, then you would probably rather that our default implementation was to throw, so that this is never going to work.
Sure, but then I don't know. Sure. Yeah. But then it comes down to the same problem. It throws, so then the call side checks. Then you can't avoid the exception. So then you just have a more expensive try because you've got to try catch.
Right.
It seems like the default behavior here is fine, though, because this is an inherently concurrent class, so you would always have to write code assuming that peek could return false, and just call read async, I guess.
Kind of like if you were calling TryPeek to optimistically see if there was any work in the reader for you to read, and it kept returning false, and that means that you might never dequeue it.
Yeah, but I mean, it also seems like, I guess I have a little bit of trouble understanding what the scenario would be, because channel readers, it's expected to have multiple readers, right? Like it's a concurrent model.
Well, the type allows it, assuming you set it up to allow it, but that doesn't mean you do. Like, you can absolutely, by construction, only have a single reader.
Right. But then it's, yeah, like TryPeek is a little, I guess it's for visitors. Like, it would let you do a visitor pattern with a reader of, oh, there was a thing, but it wasn't my kind of thing, so I didn't consume it.
It's the same reason you peek at a collection.
Yeah.
I mean, the question really is like,
but peeking a concurrent collection is, again, a little like weird.
But we do have it on concurrent queue.
Fair enough.
I mean, see,
So
maybe
the pattern
this
here
is
would be basically calling wait to read async, TryPeek, and then try read if it's the thing that you want to dequeue.
That's the thing you want, yes.
But this still means in between somebody else might have already gotten it, right?
Yeah.
Yeah, but in the case of a visitor pattern where you might have, something like TPL Dataflow that allows filtering readers too, you might have two readers, each one expects their own specific type of message. I don't know why you wouldn't have multiple readers in that case, but I can see scenarios where it might happen.
Yeah, or wrap the one reader with a filtering reader that only gives the right kinds of things to the right queues. Yeah.
Yeah, the thing about this API is it's the moral equivalent of introducing an isEmpty property, making it virtual, and having it return true by default, which we would clearly never do. But it seems to be the equivalent of that. And I'm having trouble figuring out how to make this clearly very useful API work without contorting the API surface.
Yeah, I mean, like, because in order to handle it the right way for third-party types, any caller to peek would need to as proposed, would need to back it up with a call to read in case they didn't support it. If we made this instead throw and had can peek, then that at least gives you the if can peek, I can use peek, and otherwise I either don't support your type or I'm going to use read and hope I didn't need to put it back.
Would we be willing to make it abstract instead of virtual and just say all derived types now need to implement it? Like, do people derive these things in practice?
I don't know. I mean, it's relatively new. It's been around for a couple of years. I'm sure someone has derived from it besides us, but I don't know who.
I mean, that seems to be a bit extreme. Because that's kind of an ABI breaking change. I can probably convince that we would do a virtual that always throws, though, because that would only penalize people that call the new API, which is not as bad of a break as just making a new member abstract.
Right, because
that is true. Yeah,
because making the member abstract, assuming that this already shipped as net standard 2.0, means if you implemented one in a library that's net standard 2.0, you now can't load it on net 5 because you could not have overridden the new abstract member.
Yeah, so virtual method that throws, and then like you said earlier, Jeremy, why did you call me? Because can peek return false.
Yeah.
So
it just feels like the only way that we can add something lower than, because if we had peek and take, we could have written read, but since this is inserting something at the bottom, it feels like that's the right way to do it so that we're not stuck with everyone, in order to be correct, needing to do a double call. And you can certainly say that you just don't bother reading the can peek and that you're just going to assume they support it, and maybe that'll never bite you.
I mean, this is we already have an analyzer in the queue for like soft abstract where it's like you really want to override this thing.
You've mentioned it multiple times, and I think as soon as you write up a draft, we'll greenlight it, but that nobody's pursued it.
I mean, I guess we could make it through. There probably aren't people who implemented this yet, so it would probably be safe and not cause issues, I imagine, right now.
Yeah, I mean, to me, the can one, I would only do the can one if we truly believe this is an optional feature, right? On streams, it makes sense, right? Because you basically say, like, a stream can technically be only writable and not readable, right? So that pattern makes sense. You would only do a can API here because you have a throw implementation, but realistically, we don't want anybody to throw, right? Like, we want everybody to support TryPeek. So this would only be unfortunately, you loaded something that is like from 3 versions old, and so the person didn't override it. But the expectation really is that people should support TryPeek. And
funny enough,
we would just support it in the built-in types, and that's probably already handling 99% of the usage of this type. And then for the more advanced people, it's like, you just have an analyzer or something else that tells them you really want to override this.
So should we go back and remove can count?
Can count. Where's can count?
We added that earlier in .NET 5.
To what? To ChannelReader?
We added count and can count.
Is this something where we said like maybe you can't count because it's infinite, or did we say because it's not overridden?
Well, count is how many are. I guess I don't know if we even talked about the concept of an unending, a reader that you can always read from. That is infinite.
Dev random.
No, because I think that to me that's the difference, right? Because you would say that it's a concept that may not be present even if I'm compiling against the latest version, right? Versus the other one is really more of a versioning problem where the earlier version just couldn't give you the API to override to begin with. But like, because if we add these can things, we basically ask everybody to call these APIs now. And then you have to have the else case. And I'm not even sure what you would put in the else case here besides throwing, right? It's like, well, my reader or my consumer of the reader doesn't work unless I can peek, so tough luck.
Right. It's the can. Essentially, what I look at here is for can peek, is if you needed peeking because you're doing something like the visitor pattern, it's when you got the original reader. If it said it can't peek, you're going to wrap it in a I remember one item reader. And now can peek is true, and you never call it anywhere else in your code. It was just an uptake problem. But I can imagine, especially because of versioning, that you are a reader, or you have a reader that is reading from some other reader, and it doesn't have peek, so you can't have peek unless you do the holdback of one yourself, and maybe there are algorithms that you can only do destructive reads, and so maybe there would be readers, since we didn't declare it as something that was part of the original definition, that might make sense to them of not being peekable. But I agree, it's less likely than I don't want to agree that you can count me.
Yeah. I mean, if we have uncountable readers, if we have infinite readers, and I can think of a scenario where you can't peek, but you can read. Dev random is one that I mentioned earlier. Didn't one of you earlier have the brilliant idea of making the ref assembly have an abstract member, even though the real implementation is virtual, not abstract?
Yeah, that was my suggestion of how we can introduce new abstract methods. I think my camera's off, so you didn't see my air quotes. Going forward, so the ref would say it's virtual, and then an attribute must override that. Then we make the ref generator turn must override into abstract. And now, if you're building a type against Net5, it would tell you, hey, you have to override this. And then if you're building it against Net Standard 2.0, it wouldn't see it, so it wouldn't tell you. But
I like that idea. But
Yeah,
it seems like a larger conversation.
That's a math breaking change. Source breaking change.
Right, but
only if you retarget to .NET 5 and then attempt to recompile.
Yeah.
Right.
Well, yeah. I mean, that's what we hope people do, right?
Yeah.
Right, but whether it's that or an analyzer that produces warnings, and you're like most build environments that I've ever seen, and warn as errors turned on, much to Jared's chagrin. That
analyzers wouldn't have to be warnings.
Fair enough, but
I mean, I think I'm okay with that because I mean, even if you had a soft, abstract analyzer, we would probably have it on by default and probably give you a warning at least by default, right?
Yeah, but the developer has the option of turning it off. They don't have the
that's
ability
fair.
to turn off our reference. Right.
But I guess I'm sort of okay with that because source breaking changes to me are nowhere near as bad as binary breaking changes. Due to
No, but this case is really bad. Your code base cannot work unless you do more work to add additional methods to your types. Like imagine we added a new soft abstractor, I think as we're calling it, to stream. How many code bases could simply not move to .NET 5 without a crap ton of work?
But I think we would never do this on a base class as widely used as stream. Like we don't think a lot of people subclass channel reader.
I think we would love to, because then it would let them actually have the array things implemented in terms of the span things instead of the other way around.
Right, and we want to be able to encourage people to add their overrides on stream. So I'm not sure why we would use a different solution there.
Yeah.
Yeah. So in that sense, that's what I'm saying. To me, it's kind of less concerning than the binary breaking changes. So just making an abstract to me would be a no-go. But the reference assembly abstracted implementation being virtual seems doable. But yeah, I would agree with you that it would be bad for widely used types. So maybe we just have only the soft obsolete with an analyzer that gives you a warning, and then call it a day, because that we can use everywhere, and then good enough.
And then, if we were actually defining this feature, there would be possibly a difference between, hey, I'm a default throw implementation, you really need to override this, versus like what we did on stream, which is, I'm a horribly inefficient implementation, please override me and make me better. And because one of them is I won't work, and the other one is I will work, but you may not like it. But yeah, so the fact that I came up with a scenario of that you could wrap it with a I hold one, or do one value hold back on read to implement TryPeek with a wrapper means I think that there's value in exposing the can peek, and then at that point it should be virtual throw. But otherwise it's fine. Then I will say, in general, we have the discourage public virtual, but since you have no, I assume there's no state or argument validation here, so it's probably fine.
Emo, can you click the link at the top? I don't remember what the scenario was that was driving this. Yeah. All right. This is basically the multiple visitors thing.
I think everyone's in agreement that the API is definitely valuable. I haven't heard any pushback against the API in principle.
And I was playing with at one time, trying to read and write to a message queue using ChannelReader and Writer.
Mm-hmm.
And like message queues, you kind of wanted the same functionality where you don't pull the message from the queue until you actually are completed processing it. That way, if your service dies, it's still in the queue and somebody else can pick it out. So like a TryPeek in that scenario is kind of what blocked me.
There are variations on that too. Like you want to peek at the at what's there to get some information about it, do some pre-processing, and then pull it out, I guess. Yeah.
Because I guess on ChannelReader, I mean, just making sure here, read is, or the things that do the reading are public virtual, right?
Abstract.
Sorry, they're the thing that you write an override for, the word that goes in front of it is public and not protected.
Correct.
Okay. Because if the virtuals were protected, we could make the base class do the I will hold one value for you. But since we exposed the virtualness directly, we can't.
We could. It would make those base implementations way more expensive.
But you wouldn't be able to get in front of the base class couldn't get in front of TryRead to say that it needs to return the held back value first. If TryPeek was called and did a hold back, or did read hold.
But even if it was structured the way that you're saying, it would be a lot more expensive because every call to read would also have to consult that special holdback before delegating to the derived types implementation.
Right.
Basically, you end up having 2 layers of all the functionality.
Right. We could, if we could have a different discussion, if all the virtual/abstract members were protected.
Sure.
So, would we call it CanPeek or CanTryPeek? I would probably propose CanPeek because we might want to have a peek method at some point, right?
Yeah, I would say CanPeek.
Yeah.
I mean, in theory, we could add a peek async, and it's basic. That once we have TryPeek, a peek async, I believe, I'd have to think through it more, but I believe it could be virtual implemented in terms of wait to read async and TryPeek.
I think that's correct. A philosophical question on this type. Is this type generally meant for sources to send data to this thing and then to basically push a notification to any listener, I now have data for you? Or are listeners intended to just effectively pull it as they have availability? Or both?
Both. It's really just a general handoff of data from one party to another, or from multiple parties to multiple parties, or any variations on those. And the consumption pattern might be a single reader who just wants to consume things as fast as they come in, or multiple readers that are parallelizing over input produced by any number of producers. And so they're all just sort of pulling off the next thing that's available. It could be someone who's just coming along and polling and grabbing everything that's there when when they have an opportunity. So it's all variations on that. Why do you ask me that?
I was trying to figure out if this really made sense in a greater context of like a has data event or something, where the event gets triggered and you just get the T, and that doesn't dequeue it, it doesn't read it, it just says here's some piece of data, and that event would also be the equivalent of the peek. Basically just designing on the fly. I'm not saying it's a good idea to do that. I'm just wondering if such a system can be built on top of all of this, or vice versa.
I will say, I believe, I have to double check. I believe I verified that this can be implemented. We have basically 3 implementations of ChannelReader internally right now. And I'm pretty sure I verified that functionally it can be implemented on terms of, for all of them. And there is one for which it adds non-trivial, expense. It's trivial to implement, but ConcurrentQ.TryPeek has a fair bit of overhead. And the main channel reader is implemented in terms of ConcurrentQ. So this TryPeek will inherit that TryPeek's expense.
Okay.
Implementing TryPeek, I believe it's the first API we introduced that sort of enforces ordering. Whereas if you call TryPeek, you then require TryRead to pull out that same result.
Yeah, that's why it would be difficult to have a random channel reader with TryPeek.
Yeah, is there a... I could see implementations of queuing logic that could be made slightly more efficient if they didn't have to respect ordering. So we're kind of boxing ourselves in here a little bit.
Well, they would just say CanPeek is false.
Yeah, I suppose so.
Once we have the broadcast of I don't support peeking, it's I didn't support peeking. Don't do it.
Good point.
Just because if you got something back from TryPeek, somebody else might have read it, right? Afterwards and pulled it out of the channel?
Yeah, but I think the expectation would be if you have a single reader and it calls TryPeek, if it calls try read, it better get the same value that it peaked.
For single reader, okay.
I think we should hold off on shipping this in .NET 5. Even though we could probably whip it out pretty quickly. I think we probably want more feedback on it than we'll get in this cycle.
That's fair. I mean, so that means we generally are okay with the API. We just don't want to put it in 5.0.
I think so. I mean, someone could convince me otherwise, but it feels like we believe there's value, but we also have some unsureties about it, and it's probably not. If we were to screw it up, it could have negative impact. So we should probably hold off until we have more previews, more people trying it out, etc. Yeah, basically get it in like as soon as we switch over to .NET 6.
Works for me. All right, then let's leave it like this. It's already 12:07, and then let's call it a day.
Thank you.
Alrighty, then everybody have a great weekend. Stay safe and enjoy your time.
Bye-bye.
Bye-bye.